So very good. Now guys, we've defined the derivative, and look, don't stress if you don't exactly know what to do with it. You're not supposed to, okay? Because we haven't yet applied the derivative. We've looked at polynomial functions in the previous video, and now we're going to move on to something called the power rule. And I'm going to tell you what the power rule is. I'm going to state the rule, and then I'm going to do a few examples with you. Okay? Now the power rule, firstly, is a shortcut for finding the derivative. Now I've given you the full definition of the derivative. It's that long formula, f of x plus h minus f of x all over h, right? It is a shortcut for the derivative. The derivative of polynomial functions. Now remember guys, you've looked at polynomial functions. You know, those are just a series of functions where we have coefficients, x's raised to different powers, and those powers are not fractions. So for example, if I have x squared plus 2x plus 3, that is a what? What type of function is this? What type of function in general is it? It's a polynomial, right? If I add on maybe plus 5x to the power of 3, and I go on and I raise the powers higher and higher, it is still a polynomial because we have coefficients, we have x's, and we have it raised to powers. That's the strict rule for it being a polynomial. Now remember, the power rule is a shortcut for the derivative of polynomial functions, okay? Now I'm going to show you what's the rule. Now there's another note I'm going to make, and that is that we can also use power rule for non-polynomial functions. And what's a non-polynomial function? A function that is not a polynomial, right? If, and this is something I made up, if written in mimicked polynomial form. So in mimicked polynomial form. So in other words, what I'm trying to say here is the power rule is strictly for polynomials, but sometimes you get a function that is not a polynomial. Sometimes you get a function that is not a polynomial, but you must find its derivative. So when you find its derivative, you can also use the power rule only if you can write the other function in a way that it looks like a polynomial. In other words, you mimic it. In the same way we said we can't find the derivative or the gradient of a single point, so what do? We take 2 points, we take a single point, and we treat it as if though it's 2. So if we have a function that's not a polynomial but we can make it look like one, then we treat it like it is a polynomial in order to find the derivative. Okay, so now guys, I'm going to look at two things when it comes to notation. Firstly, you have a function and you have that function's derivative, which is a curve which describes what the graph's gradient would look like, right? And it's also dependent on x. Okay, so if the function is f of x, or p of x or q of x, then its derivative or its gradient function is f prime of x. So remember, this is a function in itself, so is this. So if you put a certain x value into that function, you'll get the value of what the gradient is at that specific x. That's what the derivative is, right? So this is the notation for the derivative. Later on we'll look at derivatives at specific points, right? Okay, and this is the function. So if the function, that's the derivative. So if the function is p of x, then its derivative will be p prime of x. So you guys with me? If the function is y, and y is dependent on x, in other words, x is the input variable, then the derivative will be dy by dx. Are you guys all with me? That's the notation you will use. Are we good? So this is just notation. Now there's one other notation that I'm not tackling here right now, which we will also look at later on. So the power rule, people, is the following. If your function is the following for a function f of x, right, which could be a sum of the functions, is equal to a times x to the power of n, then the derivative of that function, which is denoted f prime of x, is equal to n multiplied by a and x to the power of n minus 1. Are we good? Okay, so that's our power rule, people. We're now going to look at examples of the power rule.